We're going to look at the steps to find the response in terms of sigma. First, we need to determine what expression do we need from our circuit. This might be a gain ratio, like V sub out divided by V sub in, or I sub out divided by V sub in, or an admittance, that is current divided by voltage, and it can be I sub out divided by V sub in, or I sub C divided by V sub out, or an impedance, voltage divided by current, and this can be V sub out divided by I sub in, or V sub R divided by I sub in. In all these cases, the first thing we need to do is to transform all the circuit elements from the time domain into the frequency domain. So let's start with the first example and find the response in terms of sigma of the expression I sub L divided by V sub in. First, we need to transform all the circuit elements from the time domain to the frequency domain. And we write V sub in, C sub 1, C sub 2, and C sub 3. And the inductor C sub L is 2S. We notice that if we're going to try to find I sub L, we're going to need an input current, I sub S. We also notice that we're going to use an equivalent impedance that is going to be the parallel combination of C sub L with C sub R2, C sub R3. So we write C equivalent is equal to 2S in parallel with 2 plus 2. That turns out to be 2S times 4 divided by 2S plus 4, and that is 4S divided by S plus 2. Now we're going to write current division for I sub L, and we notice that we have Rho resistors, 2 plus 2 divided by Rho resistor, 2 plus 2, plus 2S from the right resistance or impedance multiplied by the source current I sub S. Now we're going to put the value of I sub S into the equation, and that's going to be 4 divided by 4 plus 2S times the value of I sub S, that is going to be V sub in divided by total resistance, that is 4, plus the C equivalent. Putting the value of C equivalent into the equation and now finding the ratio I sub L divided by V sub in, this turned out to be 4 divided by 2 times S plus 4 divided by 2 times 1 divided by 4 plus 4S divided by S plus 2. And working a little bit more on the expression, we have that I sub L divided by V sub in is going to turn into 2 divided by S plus 2 times S plus 2 divided by 4 times S plus 2 plus 4S. And this is going to be finally equal to 2 divided by 8S plus 8, that when we factor out 8 is going to give us 1/4 divided by S plus 1. And this is our ratio I sub L divided by V sub in. We want to sketch our ratio I sub L divided by V sub in, or 1/4 divided by S plus 1, in terms of sigma. So we change the value of S by sigma, and this expression then turns into 1/4 divided by sigma plus 1. Now, expressing this as a complex number, we write that I sub L divided by V sub in is equal to 1/4 divided by sigma plus 1 plus J0, where 1/4 divided by sigma plus 1 is the real part and 0 is the imaginary part. So every complex number will have a magnitude, and that magnitude is the square root of the real part square plus the imaginary part square. And so since we only have a real part, then the magnitude is 1/4 divided by S plus 1. Now we're going to assign values to sigma in order to find values for our magnitude. If we let sigma equal to minus infinity, that's going to be 1/4 divided by infinity. That's going to turn into 0. And so we say that we have a 0 at minus infinity. If sigma goes to a value of minus 1, that's going to be 1/4 divided by minus 1 plus 1. That is a 0 in the denominator, and a number divided by 0 goes to infinity. We said we have a pole at minus 1. The next value for sigma is 0, and then the magnitude is 1/4. And then we try with plus infinity, and that's going to be 1/4 divided by infinity is going to turn the magnitude to 0, and we say that we have a 0 at plus infinity. So joining all the points, we can draw the following magnitude versus sigma. The next is to find the phase of that complex number, and phase is our tangent of imaginary divided by real. We have imaginary equals 0, so this arctangent is going to be always 0 divided by sigma plus 1. But sigma has a value that can turn into positive values or negative values. And so our expression is going to be 0 if sigma is greater than minus 1, because the arctangent, or the argument of the arctangent, is going to be always positive when sigma is greater than minus 1. And it's going to turn to plus or minus 180 because when sigma is less than minus 1, the argument of the arctangent is negative. And so the argument of this arctangent being negative is going to give us plus or minus 180. It will be plus 180 if we sketch them in the left-hand side of the frequency spectrum, and it's going to be minus 180 if we sketch them in the right-hand side of the frequency spectrum. So let's put the axis. We have 180, 0 and minus 180. So we know that for sigma greater than minus 1, all the values will be at 0 angle, and the values for sigma less than minus 1 are going to be at plus 180 because they are on the left hand side of the spectrum, and this is the sketch of the magnitude and phase of the ratio I sub L divided by B sub n.